Progress.
Okay, so in this video I'll discuss my first project, the Micromouse Maze Runner robot. So basically this is a robot that I made for All Egypt Micromouse competition. It's a robot that basically is supposed to complete a maze of 16 by 16 cells, as you can see here in this simulator. And I was the head programmer of the team, where I was responsible for making the algorithm for mapping out the maze and finding the shortest path to complete the maze in the shortest possible time. Okay, so at first I'll talk about some of my background research. So I tried testing some already existing algorithms like the TreeMax algorithm, which basically states that if the robot has visited a cell twice, this is a cell. If he has visited a cell twice, then he shouldn't come back to it. Like this is to avoid dead ends and so on. But I discovered that this algorithm doesn't work for sufficiently large mazes, like this 16 by 16 maze. So there was also the floodfill algorithm, which is basically a recursive algorithm where you call the same code again and again and again, which wasn't really practical for a small programming board like Arduino. So instead I driven my own algorithm, which kind of expanded on the TreeMax algorithm. The algorithm basically says that when the robot is confronted by three possible different paths, like if I run right now here, if the robot here has to either go to the front, to the right, or to the left. In this case, the robot hasn't gone to any of these three routes yet, so I programmed the default route to be the front, so he'll continue forward, as you can see here. But if he had he gone to the front and to the left before, here or here, he'll go to the right, explore it, and then come back here, and so on. So basically, if he has visited a pass once and a pass is left unvisited, he'll go down the unvisited pass and so on. He'll just visit the pass that has been visited the least amount of times. So now let's continue running this code, and I'll explain what exactly the code is doing. So basically, the robot is trying to map out the whole maze. The robot is going through each individual cell, and as he's going into each new cell, he basically maps the XY coordinate of that cell. So this here is 0, 0. This here is 15, 15, because my arrays start from 0 to 15. And he also maps the number of walls around the cell. For example, this cell has a wall on the right, a wall on the left, but no wall on the front. This cell here has a wall on the right, wall on the left, but no wall at the front also. This one has a wall on the front. So he continues to map this maze cell by cell, wall by wall, until he gets to know the whole maze, how the whole maze looks, and he transforms that into an array of zeros and ones. Zeros being for open paths, and ones being for walls. We'll see that later here on the terminal. So anyways, the robot will continue exploring the maze until he has gone through each individual cell, because he want. Okay, so we did that. Alright, so as you can see here, this is the mapped out maze by the robot. As you can see here, zeros are the space right here, the ones are the walls, etc. So what will the robot do? The robot will then make his own solution to the maze. He will try to basically find the shortest possible path through an algorithm in graph theory called depth first search. I'll not go into detail, but basically an algorithm that tries every possible route throughout the code and returns the shortest possible path. We can see that here. We'll open the code. It is shown, yeah, here. This code from here to here is the code that is responsible for finding the shortest possible path. So anyways, the robot will now continue down that shortest possible path that he has found it. I'll speed it out a bit, and we'll go to the center through the shortest possible path. Okay, so another aspect that I would like to talk about in this project is basically the movement algorithm, because when the robot moves forward, that's the only moving code that the API, the simulator that I'm using, allows me to use. So moving forward, when the robot is in this direction, here, as you can see here, moving forward in this direction is basically moving east relative to me as an observer. So the robot, like, after he rotates left and right, the moving direction varies from north to east and from east to back and from back to like west. So I made sure to keep track of his position as an x and y coordinate, and also keep track of his current direction. And whenever he rotates right and left, I make sure to update that current direction. So when he rotates right and his current direction is forward, his new current direction will be east, and so on. This is honestly one of the projects I am most proud of, mainly because this project has my own like new algorithms that I haven't been able to find on the internet, and it also was quite long. It took me about 15 attempts to finally make this code work and solve a maze, and it allowed me to really succeed at the competition. So I'm really proud of this project. Thanks for listening.